Check one. Yep, mic is there. Okay.
Take it as fate. If there's jamberries left, I'll buy jamberries. If there's not, it's
Hey everybody, Smitty here. Starting up a stream, and my mic is having issues. Yeah, hi. It's in the middle of the day, middle of the afternoon. I don't normally run these this time of day, but I've got the day off work for various different reasons, and I've got a project that needs doing, and my glasses are filthy. Probably should have done this before starting the stream. Anyway, yeah, so there have been a couple of different episodes recently where I've done some things and haven't shown you the results of them. The results were I placed an order on Osh Park, and then I haven't really come back to talk about them yet. So I want to talk about those a little bit, and then I'm going to start working on another electronic circuit board that I have a need for, and I thought I was going to be able to rig together with some things that I bought off of eBay, but for reasons that kind of surprised me, actually, but in hindsight should have been perfectly obvious, as most realizations are. I need to design it myself and design it a little bit differently than what I can get on with off-the-shelf components. So the first of the two previous projects I wanted to talk about was my little speaker mixer. So let's see here. Where are you going to focus on that? Come on. Focus. Oh, I hate these cameras. Okay, so what this is this is the little board that I made that is supposed to take in multiple speaker level inputs, like the speaker out from my D700 mobile rig and my FT100 mobile rig, mix them together into a single line level audio signal, not a speaker level audio signal, and then you take the output of that line level and feed it into a power amp and put it back up into speaker level, and then route those over cables to the front of the car where it'll go into a single speaker. So I don't have to run multiple speaker lines, one for each different radio. Right now I've only got 2, possibly 3 inputs in mind. I built the board for 4 just because it was easy, and I like powers of 2. But I'm going to use the D700, the FT100, and probably the output from the Raspberry Pi, although I don't know what kind of audio I'm going to use out of the Pi. Or even if I'm going to have a Pi in there. It's kind of a hand-wavy, iffy thing that I might be adding to this kit. But anyway, boards have shown up. They look good. I haven't done anything with them yet. I haven't actually assembled them yet because I've been working on this other power problem. That was going to be the primary subject of today's stream. Let's see here. What was the other thing that I wanted to talk about? Oh, thank you, Nick. I just got a text message from Exploding Lemur saying, "I'm watching you." Because that's not creepy at all. Anyway, the other project I wanted to talk to you about was my bedside clock project, WS2812 based clock. I posted some videos of this on Twitter. It's a little hard to see because I've got the light brightness turned down so much because I intend for it to be a bedside clock. But you can see the colon blinking. Wait, there it is. You can see the colon blinking, and then the hours and the minutes over there. I just have that hooked up to it as a voltage meter, so I can tell how I've adjusted the switching power supply here. So the whole problem, there are several problems I found with this board. I'm not going to have to rev the display board, but I do have to rev and do another version of the engineering board. You'll see how that there are kind of 2 boards sandwiched here. The control board is only half length, and then the display board is full length. The control board needs to be revved. There, ran into a couple of problems with it. One, the ESP8266 is a 3.3 volt device, but the USB charging is 5 volt. And I have those two tied in parallel without any sort of separate regulation between the two. So I got to go fix that. I'm going to stick like a 3.3 volt regulator on the output of the 5 volt output of the big switcher. Because the the ESP8266 doesn't take a whole lot of current, so just putting a linear regulator there will be fine. I also want to expose the buttons to the top of the radio so that you can get to them and use them for controlling the thing. Oh, and the other one is that I wanted to add the automatic programming stuff. When you go into Arduino and you click Control U for upload, it will toggle the DTR and DSR or CT, whichever, the flow control pins, and uses them. There are 2 output flow control pins and 2 inputs. The 2 outputs from the serial port to the microcontroller, it will trigger them in such a way to pull down D0 and then reset the device. And so you can do all of that, the button press funkiness, automatically with the programming software. Problem: most serial modules only expose one of the 2 pairs of control pins, not both of them. So you only end up with 1 output and 1 input. But there are games that you can play with some diodes and capacitors to have that 1 output. You use that output to directly control D0, and then you use a capacitor. You put a capacitor between it and the reset, and when that transitions from high to low, that capacitor will go low for a while, but which will trigger the reset. But over time, it'll fill back up. The capacitor will fill back up, and once it goes past the threshold, then it will pull the chip out of reset. And so basically with a single transition from high to low, you can pull and hold the D0 line low for long periods of time and also trigger a pulse to do the reset. A little bit more complex, a few more components, and I won't have to push the buttons to be able to program the thing. I can just hit Control U in Arduino, and it will automatically reprogram the microcontroller, which would be a neat feature. So I'm going to do those. So those are the things that I got to rev on that board, on my little clock. But otherwise, I'm really happy with how it turned out. The digits look like digits. Yeah, I don't know if you can see the numbers very well because it's so well front lit. But I'm pretty happy with how that turned out. I think those are the projects that I had to catch you guys up on. That's all I have in my notes. So let's go ahead and talk about the current project. All right. Back up. I have a new car, as you all know, because I've said it before. I have a new car, Prius Prime. I love my Prime. My old Prius had the 12-volt battery in the trunk, in the back of the car. And so I had all of my radios mounted in the back of the car, and it was like a 4-foot cable to get from the car battery to the radios. And running big, thick, heavy gauge wire 4 feet to get from the battery to the radios wasn't that big of a deal at all. It was pretty easy to do. And I could run my D700 on high power and the FT100 on, I got it up to about 75 watts. I was probably a little bit more than I should have, but I did it and it didn't cause any problems. I never got it all the way up to 100 watts running off of that battery. I was worried about blowing fuses or over, big voltage drops in lines, and I didn't have it instrumented, so I didn't know exactly how bad it was going to be. So I didn't want to push it. But on the new car, the 12-volt battery is in front, where it is on a normal car. Most cars, the 12-volt battery is up under the hood in the front. And that's where they moved it for the Prius Prime, because there's no space in the back. It's all filled with a high-voltage battery, and I'm not going to try and tap into that. That's madness. I'm not going to try and tap into that and use that for radio stuff. So if I want to run the car, I don't know why I'm wearing headphones. I'm not listening to anything. If I want to run the car off of, if I want to run the radios off of the car's built-in 12-volt battery, I need to run some very large gauge wire. I want to be able to run my radio, my FT100 at full 100 watts, which is like 25 amps, 20 amps, 25 amps around there. I think it's fused at 30. And if I'm doing that and my D700 decides to transmit an APRS beacon at the same time, I usually keep APRS on high power as well. So if I'm transmitting my FT100 at 100 watts and my D700 at 100 watts, or at 40 watts, that's 35 amps, 40 amps, somewhere around there. And that's a lot of current. Admittedly, it's only a quick burst, but I would rather not have to run the big, thick, heavy wire gauge from the front of the car to the back of the car to do that. Probably 8 gauge or so. I don't know. There are calculators out there that would tell me, it's a 12-foot run or so. So instead, what I want to do is I want to put my 20 amp hour Biono power lithium iron phosphate battery in the back, right next to the radios. Keep the leads nice and short. It will provide all the high power needs for my radios. When it needs to pull 40 amps, it'll pull it from the battery, which is, 2 feet away or less, 2 feet of cable away. And then, but I don't want to have to like pull the battery out and recharge it, right? So I want to be able to charge the battery from the car, but only at a limited amount of current. So ideally, what I would have is, my car source over here, 12-volt electric system. It's actually like 14, whatever that voltage is, and it varies, right? Whether the car is turned on or off, whether the motor's running, whether it's charging its 12-volt battery from the high voltage battery or not, whatever. That power is variable in voltage. But I want to take that in. I want to run it through a device that is a battery charger, basically, right? And the battery charger, the way you charge a lithium iron phosphate is you have a maximum voltage and a maximum current. If the battery is trying to draw more current than what the maximum is, the charge current, in my case it's 4 amps. If the battery is trying to charge more than 4 amps because it's really discharged, then the output of the charger needs to drop that voltage, the output voltage, until it reaches the point where it's charging at 4 amps. And so the output of your charger is variable. It will go up to the maximum voltage, which is 14.6, 14.4, depending on how you want to charge it. So it'll go up to that. But if it were to dump that across a dead battery, the battery would draw 20 amps, 30 amps, 40 amps, whatever charge current it wants to draw at that, way more than is healthy. They say that the best charge current is about 4 amps, which will slow it down, but it is the recommended charge current. You could probably do it 5, 6, 7 amps, 8 amps, something like that, and still get away with it. But I want to stick with their recommendation. So they're recommending 4 amp charge current. So that means I need a module that will take whatever coming from the Prius, turn it into an appropriate voltage to charge that battery. When it's dead, it'll drop the voltage to the point at which the battery is drawing 4 amps. And then as the battery charges, that voltage will slowly rise over time, right? And eventually, it'll get to that point where it's risen up to 14.6, and then it will stop there, and it won't rise anymore. It'll stay at 14.6. Now, the charge current at that point will start decreasing, because for it to continue to pull 4 amps, you would have to go over that voltage, but we don't want to go over that voltage. So constant current, it's going to be drawing a constant 4 amps as the voltage rises up to the maximum voltage. And once it hits that maximum voltage, then the current consumption will start dropping down. And there are plenty of modules. Voltage. So we don't know what our input voltage is. It could be, as low as 12 or 13 volts. It could be as high as like 15 volts. I don't know what it's going to be, but I need the output to be very specific. Sometimes you might be in conditions where the input voltage is less than your output voltage. You might be in conditions where your input voltage is more than your output voltage. And you can't really predict that. Consequently, the very common DC to DC switching modules you can get on eBay and Amazon and various other places that have constant current and constant voltage adjustments, they will only work. Let's say we got a buck module. Buck means drop down. If we got a buck module, that will only work if your input voltage is always above your output voltage. And I can't guarantee that because the typical voltage in my car is about 14 to 14.4. It won't get it up to the 14.6 that I need it to be. Or like 13.8, 14, somewhere around there. It varies. But I can't use a buck module because the input voltage isn't high enough to get up to my target voltage. I can't use a boost module either because boost is where it will only go up. And I found this out when I was doing my trip to Kansas. This is I think it's a 10 amp, maybe 20 amp. I don't remember. This one's a nice and beefy one. I mean, look at that heatsink. This is a really nice, this is a boost controller. This is a boost module. And it's got a constant voltage and a constant current adjustment on it. And the problem is that it will, if you've got a low voltage input, it will boost that up to your output voltage. The problem is that in the conditions where it's high current, where the battery is trying to charge with high current, it is not able to drop the output voltage below the input voltage. So there are situations where I would run off the battery for a while, the battery would get discharged, I would turn the car on, and the car would now be putting out a 14 volt signal or whatever it is to my boost module, and my boost module is not able to drop the voltage below that, but the proper charge voltage to do a 4 amp limit would have been below that point. And so it is not able to drop it any lower, and consequently you end up dumping a whole bunch of current into the battery, more than you need. So what is ideal is to get a boost module that brings it up to some high voltage, really high voltage, and then a buck module that takes it from that high voltage, low current down to the appropriate voltage. And as long as that intermediate voltage is always above where you want your final output to be, then you'll be in good shape. I could rig this with 2 separate modules. Luckily, I don't have to. There are modules out there similar to this one. I've already got it mounted in a box, but it is a buck boost module. And so it's basically a boost module followed by a buck. And you always want to do boost first, then buck, because then you have higher voltage, lower current in the middle. If you did buck, then boost, you'd have lower voltage, higher current in the middle. And current is typically our limiting factor in these things. You need to have bigger traces and bigger wires and bigger transistors and everything like that. So it's generally better to have a higher intermediate voltage and a lower current in the intermediate, and then go down. Anyway, so this module here does not do as much power as this one does, but I think that's going to be okay. It will do. It claims it's rated for 8 amps. And so I'm going to be limiting it to 4 amps, but it is a buck and boost module. So it'll boost up and then buck down to the appropriate voltage. So no matter what input voltage I give it, it will always be able to select the appropriate output voltage to limit the current to the right point. So I got this all rigged up. It's got 2 Anderson power poles here. The top one is the input, the bottom one is the output. I haven't labeled it yet, but I'm going to. And then I've got the little switch here, which is a 3 position. It's a up, center off, and then down. And what that does is it connects either the input voltage or the output voltage to this little meter that is on the front panel. So this meter is a voltage meter and a current meter. The voltage is, where it's measuring, either the input or the output voltage is selectable by that switch. The current is always measuring the output current from the module to the output of the Anderson power pole there. Because that's the one that I need to be able to adjust to the proper charge current on the battery. And so I wired this up, and I hooked the input to my power supply, my bench power supply over here, not a bench, excuse me, the rack power supply that's got, powering all of my radios and everything else. So I gave it a good 14.4 volt input. I hooked the output up to some to some resistors. Actually, let me go get them. Hang on. So I bought these 3 ohm 100 watt resistors here. They are just this part. There are 2 of them on here. And then I mounted them on a CPU heatsink. This is a Intel Xeon CPU heatsink, a nice big copper thing that I had. It was a leftover from a work project many moons ago, where I was going to use it for some sort of a steampunk kind of Seebeck generator thing. But I have the big, huge copper heatsink with a fan on top, and I just bolted the 3 ohm resistors to the bottom of this. So the idea is that, and I'm not going to go over the math right now, but if you put the 3 ohm resistors in series, you get 6 ohms. It's actually like 7. I think there are 3.5. The precision's not very good on these, but I measured it at about 7 ohms, but that's good enough. If you run 7 ohms across 14.6 volts, you will get less than 4 amps, right? You get about 2 amps, 2 and some change. And so I use the 2 3 ohm resistors in series to adjust the upper voltage, the constant voltage side of it. Then I need something that will draw 4 amps at a voltage something less than the 14.4 target voltage, so that I can see the module drop the voltage down to the appropriate, drop the output voltage to the appropriate voltage so that it current limits. And so one of those 3 ohm resistors should drop it to about 12 volts. 3 ohms, 12 volts is about 4 amps, right? Ohm's law. So If I only use one of those resistors in series, not in series, only one of those resistors on the load, then the output module, if I adjust it to 4 amps, should drop that output voltage to 12 and some change volts, right? And that worked out pretty well. I was testing it, and that seemed to do okay. I'm not super impressed with the quality of this module. I think maybe the 10K ohm resistors, the little trim pots in there, I don't know if you can see them, probably not. The little trim pot adjusters down in there, you can kind of see the brass head right in there. Anyway, I think those are kind of dirty. They're not very good quality because the adjustment was kind of twitchy. Anyway, I'm going to try and find a better module than this one. I got a couple on order already. But the idea is that I can use these resistors to adjust the test points, or the adjust points on the module. And all of that was great. Then I went to go try it on a real load. So I still had the input hooked up to my power supply, but then I grabbed the power into my radio and hooked it up to the output. I did that, and current was doing weird things. The current measurements were not what I expected. You turn on the radio and it draws like 0.9 amps constantly, and then I key up the radio and the current consumption dropped. Like, that's not right. What is going on here? When I transmit on the radio, I would expect it to go up pretty dramatically, and I was hoping that I was going to be limited, that it was going to limit. Oh, excuse me. Let me clarify. This is all connected to the output of this goes to my battery, and then the battery went to the radio. So I was hoping that we were going to see the current limit, and that the battery was going to pick up the difference in current. So that this module was going to output I think I had it set to like 3.5 amps. This module was going to output 3.5 amps, and then the battery was going to pick up the difference and power the radio. And then when you unkey, the power supply would still output 3.5 amps as it's charging the battery, as it's recharging the battery, and for a while, and then eventually it'll top it back off again and be done. But that's not what happened. It was pulling like 0.9 amps. And then when I keyed up, it dropped to like 0.5 amp. And I'm like, that is not right. And so I hooked up another current meter that I have, and I can't remember whether it was on the input or the output. Anyway, I hooked up another current meter, and the power, it was in series with this current meter. So it was the output of this into the battery, and then from the battery into the radio. And they were mostly agreeing. There was a little bit difference, but even the current from the battery into the radio wasn't doing the right thing. And for the life of me, I could not figure out what was going on. Turns out, it is really easy to measure current in the ground lead, the negative lead of your power, for various different reasons. It's just it's easier to measure it there between like 0 volts and 0.01 or whatever across your shunt, rather than at the top end in your 12-volt line. And so these current meters do exactly that. They have it's a 3. So there are two pins that go into power the module, right? That's just the power supply. It doesn't have anything to do with the metering. It's just powering the meter. And then it's got these 3 other pins. It's got a black pin, a blue pin, and a red pin. The red pin is your voltage measurement, and it is measuring relative to the black pin on the bottom. But the blue pin is the current. And so you have current going into the blue pin, goes through the shunt inside the meter here, and then back out on the black pin, on the ground pin. So you are measuring the current going through the negative side of the sensor for the +5, for the voltage sensor. That is not entirely unlike, stand by, this. So I rigged this up many years ago. This is a standard volt-ohm meter, right? And it's pretty common. They have a common lead here, and when normally when you're just using the pointer probes, you hook up the black and red to these two here, and you can measure voltage. You have the common, which is ground, and then you have a voltage probe. But you also have the common and a current probe over here, and you put these two in line with what you're trying to measure. So what I did is I made a little rig that's just 2 Anderson power poles, 2 Anderson power poles. Both of the positives for the Anderson power poles go to the voltage probe on my meter. And then the negative on one of the power poles goes to the common, and the negative on the other power pole goes to the ammeter. And so now I can stick this in line with whatever it is that I'm measuring. And all I have to do is switch it over to volts to measure the volts, and then switch it over to the 10 amps to measure the current going through the device. And I can do that while power is still going through it, and it doesn't interrupt anything that's going on with this power. And so it's a very easy way of as long as you put this in line ahead of powering your thing up, you can measure voltage and current individually. This was super easy to rig up and cheap. I already had the banana plugs available from a speaker project I'd done many years ago. But it's, it was an easy way of doing this instead of getting one of those little blue modules that they make for RC car chargers and whatnot. But you'll notice, because the common and the current meter, the common is the negative side for the voltage meter. So to use that common for current, you also have to measure the negative side of current. Here's the problem that I ran into. My radio is tied to the power supply through my shack's common ground system. So there is a bar on the back of the rack that's got big, thick gauge copper wire that goes from that bar to the radio, and from that bar to the power supply, and from that bar to various other devices on the back of my rack, right? So this is a safety ground. This is a make sure everything's at the same potential. Unfortunately, that ground is lower impedance than the negative leads going from the power supply into this module through that module, through the current sense, which already, intentionally adds a little bit of impedance because you got a current shunt in there. You need to measure the voltage across that current shunt. So you've got an intentional bit of impedance here. And then out from that into this, into the battery, and then into the radio, right? So that path was a higher impedance than the path just from the back of the radio through my common ground into the power supply. It was a higher, so the power line path was a higher impedance than my safety ground path. And that is good from a safety perspective, but it's bad from a current perspective, because now my power current is not traveling through my power supply, and that's going to cause all kinds of problems. There are huge tomes written about grounds and grounding systems and ground loops and things, and I'm not going to begin to try and go into it here. But what this has shown me is that I've got a pretty gnarly ground loop system, or a pretty gnarly ground loop problem in my system. And it's really making me think about how I need to be doing this. I'm going to have to probably get rid of that common ground tie in the back of my radio system and rely on the power as my ground, my common ground, which might be interesting. But in the immediate term, this means that to accurately measure the current flowing through my power leads, I need to measure that current on the positive side. And that meter's not going to do it. And I am not aware of any similar meters to that will be able to measure current on the positive side. So I'm going to have to make one. And that is what I am doing today. So hold on. Do I have that set up yet? There we go. Okay. So, by the way, this is all streaming on my new laptop. So if things are different or a little weird, it's because I got a new computer that I'm trying to figure out. But hopefully everything should be okay. I've been having some issues with the USB ports, but my keyboard and trackball seem to be hanging out okay. All right, so I'm done with those notes. Let me make that go away. Okay, so let's do a quick search for eBay. Yeah, we'll just do that. Current sensor. No. These are the ones. Okay, these are all over eBay. Look at that. So what this is a module that, are you not going to zoom in? No, of course not. So what this is a small SOIC8 chip that has 2 pins are tied together as an input and 2 pins are tied together as an output. And this one can measure up to 30 amps. How they get 30 amps through those 2 little tiny pins, I don't know. But that's what they claim. But the idea is that this is, if you stick these 2 things, in your path, so you have an input on one side and an output on the other, then it will measure the current. The big advantage to these, the ACS 712 modules, the big advantage to these modules is that they are galvanically isolated. So what it's doing is it's actually measuring the magnetic field caused by the current running through that wire. So the stuff on this side is isolated from the stuff on this side. There is no common ground. So I can measure either the positive side or the negative side, and it makes no difference whatsoever. I do need to provide a VCC and a ground on that side, actual power and ground to power that chip. But we can do that pretty easily, and the output is a voltage that is proportional to the amount of current flowing through it. And then the ratio of current to voltage is dependent on which module you have. That's what defines the 30 amp there. The 30 amp defines the ratio. I think it's 66 millivolts per amp, I think, is it? So it's basically a voltage from 0 to 2 volts. So that's the kind of module that I want to use, but I don't want that form factor because there's no way to mount it and various other things. But I am going to use that chip. So what I really want to do is I want to have a 3-port. Here, let me go back to the view of me. What I want is to have a 3-port module with an input and a current sense on that input, then a battery with a current sense on the battery, and then an output with a current sense on the output. And then since all 3 of those are tied together, just have a voltage sense from that voltage to the ground. And so that's 4 analog voltages that I'm looking at there. 1 for each of the 3 current sensors, and then 1 for the voltage sense. And yeah, that is... where am I? There I am. So that's what I'm trying to do today. Now, having said that, I just had a visitor show up at the door, so I need to get moving. I am going to come back and start this again a little bit later. But I think this is a good part 1 of this series. So, yeah. Let me check my power meter I have for RC stuff. I don't recall if it has a shunt on the positive or negative rail, Exploding Lemur is saying. Can check in a few hours when he gets home. Okay. Yeah, Nick, go ahead and do that. I'd love to see that, but... it's somewhat irrelevant because I'm going to be doing this anyway because there are some other aspects to this that I want to make sure and do. Part of the problem is that measuring the voltage of this thing is going to be weird because you have to measure it between ground and positive. I see it, honey. I'll be there in a second. I need to measure voltage between ground and positive, but to do that, I now need to have a ground reference, and I want to make sure that my metering does not become the low impedance path. I don't want to run any current through my voltage metering, so I need to find a way of isolating that so that it does not affect. And I have an idea of how to do this. It's not going to be galvanically isolated. So if there's a large difference in grounds, it'll still be a problem, but it'll handle small differences in grounds, like up to, depending on what values of resistors you use, up to like a volt or so. And we shouldn't have anywhere near that, near a volt of difference in ground. It should be hopefully still like all within millivolts. But yeah, I'm going to go into that in a second episode because I got some visitors that just showed up. So I'm going to go. We'll be back later, probably today. I don't know what time, but hopefully later today. And yeah, so thank you very much for watching. Sorry for cutting this short. And we'll be back in a bit. Be good humans. Thank you very much. And we'll chat with you later. You going to say hi, Zoe? That's my daughter, Zoe. She's one of the best solderers I know, by the way. It's true. Can you say hi? Yep, there she is. Anyway, talk to y'all later. Thanks.